Okay, let's go about dealing with some practice problems involving the addition, subtraction, and multiplication and division. You will see many problems like this where you need to do something or other, and then you got to figure out how to round the answers. So remember, there's a different rule for addition, subtraction versus multiplication, division. Let's do addition and subtraction first. To begin with, if you type this on your calculator, the answer to this one is 7.60. And to be clear, if you write that for an answer, you're wrong because you need to round according to significant figure rules. So with addition and subtraction, remember the rule is that you round according to which number is goes the least decimal places to the right. So consider 4.60 plus 3. What we can do is write it a different way. 4.60 plus 3, like this. And that comes out to 7.60. This number goes this far to the right. This number only goes this far. So since this one goes the least distance to the right, we're going to say it's the least exact number. So being that this is its furthest right significant digit, we're going to do our rounding right here, which means instead of 7.60, since we're rounding right there, we're going to call it just 8 as the final answer. So this is the number that determined our rounding because it was the least exact of the two. And so we're going to say 8 is the actual answer for the correctly rounded version. Now with these others, let's see. For this one, the raw answer is 0.058, right? Never leave a naked decimal. Let's put a 0 in front of a decimal. And how to round that off? Well, let's do the same thing. 0.008, 0.05, add them up, 0.058. This one goes, the last significant digit is here versus the last significant for this one being, last significant digit for this one being here. And since this one's the last significant digit, which is least distance to the right, as in the least exact number, we're going to do our rounding right here based on this being the least exact number. So this number is going to be the reason for our rounding, and this number would therefore be rounded at this digit, which makes it 0.06. All right, now next one. We do the same thing. First of all, let's see what that actually comes out to. 22.4420 plus 56.981 is that 79.423. 79.423 rounded to something. All right. 22.4420, 56.981. So when you do it that way, what you're going to see, well, again, the answer is 79.4230, I guess, is your raw answer. And you will be rounding here because it's the decimal that goes least far to the right. So 79.423. In other words, it just happens that actually this was the right way to, that what we wrote at the beginning just happens to be the right answer. All right, let's see. For this next one, 200 minus 87.3. All right. 200 minus 87.3. 112.7. Oops, 112.7. Oh, that's terribly sloppy, but I think you get the idea. 112.7 is your raw answer. So 200 minus 87.3. That's right. Is that going to be visible there? Let me get 112.7. So your last significant digit for this number is here. For this number, because there's no decimal, your last significant digit is here. Well, this is by far the less exact answer, so your rounding happens here. So guess what? Your rounded answer being rounded at this place is 100. It looks like the answer key online puts it in scientific notation for some reason. Doesn't matter. But the rounded version is just simply 100. One significant. It just happens that they both have one significant digit, but that's not the reason why. It's because of this whole dynamic. Okay, now the next one's more or less work the same. Let's see if there's another one kind of like, let's see, these all involve the similar sorts of things. I was hoping for one that's large numbers. It doesn't look like there's any on this worksheet. I'm going to jump ahead to one that involves 3 steps because these work exactly the same as the ones up here. There's no surprises, so there's not really much need to go over that. Let's do an example for just a slightly more complicated one, even though it actually doesn't change any of the rules at all. It works just the same. 17.95, 32.42, and 50. Adding those together. I don't even know what that is. Let's see. 17.95 plus 32.42 plus 50 is that number, which you probably can't see because of the glare, 100.37. So that's 100.37 would be the raw calculator answer. You know, you might be tempting to say, oh, one significant figure, but that's for addition, that's for multiplication division. No, we got to count decimal places. In this one, you got your last sig fig for this number here, your last sig fig for this number is here, and your last sig fig for this number is here, which means we need to round to this decimal place right here. This 0 is next to another 0, so that's your final rounded answer. Now, by chance, yes, these do have the same number of sig figs, but it's did not round this way because they both have one sig fig. There are questions where that will lead you astray. Rounded this way because the last digit at this tens place here makes this the least accurate number, and since the chain is only as strong as its weakest link, the entire answer must be rounded to reflect the least accurate number or the least exact number used to calculate it. So 100 would be the answer that we'd put here for this particular one, and I'm looking at this is for this one, so I guess I'll write the 100.37. This is the number that forced us to round, and then 100 would be our answer. I see that on the answer key they put scientific notation, which is not at all necessary. It could be done. They put 1.0 times 10 to the second to show that the rounding happened here. That's fine, but you could have also just put 100 and it doesn't matter because we're not counting how many sig figs it has. We're counting how many decimal places the least exact number is at. Again, the rest of these, subtraction, you do the exact same thing. Even if it's a mixture of addition and subtraction, you do the same thing. So there's nothing really different on this side. So that's just your addition and subtraction. And in terms of the multiplication and division, you've got to remember that's different. You do have to count significant figures. So if I take this one, we can begin just with a few to kind of get the flavor for how it works. Let's see. 13.7 times 2.5 is 34.25. Let's see, 200 times 3.58, 200 times 3.58 is 716. That's the raw calculator answers. Now, here you count how many sig figs it has. This has 3 significant figures, 3 sig figs. This has 2 significant figures. Therefore, your answer can't have more than 2 significant figures. So this is the smallest number of sig figs. So I'm going to underline that. That tells me that this number is the one that determined how I was going to round. And I rounded 2 sig figs. Oops. Here, this is only 1 sig fig, whereas this one is 3 sig figs. So because there's only 1 significant figure here, it can only have 1 significant figure here. Let's see. Final answer, 700. Okay, 1 sig fig, 1 sig fig. Here, Same deal. I can do the whole calculation, 0.00. Let's see, what is that? 4 zeros and then a 3 times 727. 0.02181. We're going to round that to one significant figure because there's 3 sig figs here, 1 sig fig here. Remember, leading zeros don't count for significant figures. If there's a decimal, only trailing zeros do. So 1 sig fig, we round this to 1 sig fig, that's 0.02. And that's it. Again, I suppose I can underline this and underline this. Those are the numbers that determined how we round. Here, we have 4 significant figures because the zeros in between 2 non-zero numbers count. And we also have 4 significant figures. That means your final answer will be rounded to 4 significant figures. So let's see. 1003 times, divided by 3.781 gives that. So we got to round to 4 significant figures, which is 1, 2, 3, 4 sig figs. That's the 1,323. All right, we'll call it that. 1,323. Now, I guess I should write the original point 194,922, and then have an arrow pointing to 1,323, boxed, and underline. It doesn't matter. They both say 90 sig figs, so I guess I can just underline both of them. They both determine jointly how many sig figs. Same thing here. They both have 2 sig figs, 2 sig figs. So they're both going to determine how we round. 89 divided by 9.0 is that big giant thing. So that's basically 9.888 repeating, which we're going to round to just 2 sig figs, or 9.9. Here, 1 significant figure, 1 sig fig, 2 significant figures. This is going to determine our rounding because it has fewer sig figs. 5,000 divided by 55 is 90.909090 repeating. Which we're going to round to 1 significant figure, which is 90. If it was 2 sig figs, we would have rounded it to 91, but 1 sig fig, we just call it 90. Same thing for multi-number questions, such as this. The same rules are going to apply. I can already say now this has fewer sig figs than the others, 2 sig figs, so this is going to determine how we round. So that was 2.3 times, what is it, 3.45 times 7.42. That's the raw answer, 58.8777. 58.8777 gets rounded to 2 significant figures, which is going to give the final version of the answer of 59. Right? Because we rounded right here, 59. Let's see, as I look over the rest of these, they all work pretty well the same way. Let's see if they, I'm just looking at the answer key, see if anything could potentially be an issue of confusion. I suppose not. So that one should pretty well do it. Let's see, continue with the rest of these. Check the answer key if the answer key is available to you, and make sure to get help if there's any questions or confusions to any of this. All right, there we are. Happy studies.